Hello, today I'm going to go over a nuclear chemistry problem that asks us to determine the energy produced when fusing 33 hydrogen atoms together. So to start off this problem, I would first determine what the difference in mass is between the two hydrogen atoms that are going to be fusing together and a helium atom. So to calculate that, we would do delta M is equal to 2, since there's two hydrogen atoms, times, we're told the mass of hydrogen is to be 2.010410 U. But then we need to make sure to get rid of those electrons. So each hydrogen atom has one electron, so we subtract the mass of an electron, 0.00055 U. And we want to find the difference of that with helium, so then we would do minus. Mass of helium is 4.00260. Then again, we must take into account the mass of electrons. So then we would do 2 times, because helium has 2 electrons, 0.00055 U. We'll move this over. So now calculating the change in mass, we would get 0.01822 U. So this number tells us that for every two hydrogen atoms that are fused together, 0.01822 U of mass is lost to energy. So this can also be written as a percentage. That would be 0.01822 divided by the mass of two hydrogen atoms, which is 4.02082. So both U times 100% tells us that 0.45314% of the mass is converted to energy. So now knowing that 0.45214% of any mass of hydrogen atoms being fused together is actually being released as energy, we can apply this to the 33 grams of hydrogen atoms that we're told are going to be used to fuse. So we can calculate this by doing 33 grams of hydrogen times 1 kilogram of hydrogen for every 1,000 grams hydrogen. And then we can multiply this by the percentage of the mass that's being released as energy. And that gives us 1.495 times 10 to the negative fourth kilograms goes to energy produced. Now all we have to do is use the E equals mc squared equation to relate mass and energy, and we can solve for the energy. So that would be E is equal to mc squared, and we figured out that the mass that goes to energy is 1.495 times 10 to the negative fourth kilograms, and then c squared is just 3.0 times 10 to the eighth squared, and that ends up becoming 1.495 times 10 to the negative fourth joules of energy. It's important to note that whenever you're determining the change in mass, you should always take into account the mass of the electrons and remove them. Because though in this problem, we could have forgotten to take into account the electrons, because they still would have canceled each other out, like they do in this equation right here, but sometimes they won't cancel out, and that can result in a significant amount in energy change at the very end. So always remember when you're determining the change in mass to take into account the mass of the electrons that that element has. Thank you and good luck on your exam.